Welcome back to James's Physics 101. Today we conquer Lesson 2, the unbreakable first law of thermodynamics. At its core, the first law is the conservation of energy. Energy can neither be created nor destroyed. Instead, energy merely changes forms, governed by an absolute cosmic ledger where every single joule is accounted for. This was proven by James Prescott Joule, who used a falling weight to spin a paddle inside a water container. The friction of the spinning paddle raised the water's temperature, proving mechanical work directly converts into heat. To mathematically balance this ledger, physicists defined a fundamental property called internal energy, denoted by the letter U. Internal energy is the total microscopic kinetic and potential energy of all the atoms and molecules in the system. We can change this internal energy in two ways. First, by transferring heat, Q, into or out of the system. Second, by doing work W, such as a moving piston compressing the gas or being pushed by it. This gives us our ironclad equation. The change in internal energy, delta U, equals heat added, Q, minus work done by the system, W. To apply this, we must define a system surrounded by a boundary that separates it from the rest of the universe. Engineers track these energy changes using a pressure-volume diagram, mapping the state of the gas along a specific path. Crucially, internal energy is a state function. It depends only on where the system starts and ends, not how it got there. Think of climbing a mountain. Whether you take a steep direct trail or a winding path, your final elevation change is identical. But heat and work are path functions. The total energy transferred as work depends entirely on the specific path taken. Let us examine some classic thermodynamic processes. First, an isothermal expansion, which occurs at a constant temperature. Because temperature is constant, internal energy doesn't change. All added heat is converted entirely into expansion work. Next is an adiabatic process, where no heat enters or leaves. Any work done on the gas instantly spikes its temperature. This rapid adiabatic compression is exactly how diesel engines ignite fuel, and how sound waves compress the air. In an isochoric process, volume is locked. Since the gas cannot expand, work is zero, and all heat directly raises internal energy. Finally, in an isobaric process, pressure remains constant. Heat addition both increases the temperature and drives expansion work. Whether in a star, a car engine, or your own muscles, the first law is the absolute accounting system of nature. Every physical change in the cosmos is just energy shifting places. The total amount in the universe remains forever constant. This means perpetual motion machines are mathematically impossible. You can never get more energy out than you put in. Subscribe to James's Physics 101, bookmark our playlist, and join us for Lesson 3, where we explore the chaotic arrow of time.